Now, let's enjoy. We're looking at the last one. 1 over x squared plus a squared. Let's go talk about him. We want to talk about his integral. We start by talking about the differentiation that produces him. And that is the derivative of tan inverse of x. So, remember, that's the only inverse we have to know. We don't have to know sine inverse. We don't have to know cos inverse. We do nothing about them. So, in terms of derivatives, let's start with the derivative of tan inverse of x. It's 1 over x squared plus 1. This is the derivative of tan inverse of x. What if I want the derivative of tan inverse of f of x? What is that going to be? Well, this is the simplest thing you've ever asked me, sir. Are you serious? Yeah, it is. Why? Let me prove it to you. Because, first of all, I know that this is now a composite function, right? Because there's something which is not an x inside. So we can't just say this is an inverse trig function. It is an inverse trig when it's tan inverse of x. When it's tan inverse of something which is not x, remember, f of x is something which is not x. Whether it's 5x squared plus 2 or 3x squared or whatever it is, but it's not an x. Or a negative x, that is not an x. So here, when we are differentiating that guy, we use the chain rule. We start with the outside. We differentiate the outside. What's the outside? The outside is just tan inverse. What's the derivative of tan inverse? 1 over that guy. So if it was tan inverse of x, it was 1 over x. So this would be the 1 over f of x all squared plus 1. Okay? Then we multiply by the derivative of the inside. What's the derivative of the inside? It's the derivative of f of x, which is f dash x, okay? And that f dash x goes to the top, and it just becomes f dash x over f of x plus 1. That is what you now have. So this is what we have if it is tan inverse of f of x. What about if I'm integrating? Who am I going to be working with in my integrals? Okay, I mean, let's just put tan inverse of ax plus b, okay? We don't have to, but let's just put it. What is this going to be? Tan inverse of x plus b? All right, we start by the derivative of the outside, which is tan inverse. It is going to be what? 1 over, instead of x squared, it is ax plus b, all squared, okay, plus 1, okay? That's the f of x, okay? The f of x comes a squared. Then we multiply by the derivative of the inside, which is a. So it's going to be a over ax plus b all squared plus 1, right? Either way, now let's go to do the integrals, okay? What am I now going to have now as the integrals now? What am I going to have? We want to just look at the integrals and let's see what it is. All right, so now what would happen with our integrals? Okay, so for the integrals, let's just say, I would have to tell you one more thing before we do this, which would help. It's not, the inverse tan of ax plus b actually doesn't help us in any way. There's a tan which helps us. You know, when you do inverse trig, you see this for those that want to do engineering. I guess you see it when you do engineering mix. There's a tan inverse they like, which is for x over a. It's a special one, okay? So you don't have to know this one. This one has no help at all to what we're about to do. So, but if you do this tan inverse of x over a, what happens is when you're doing this, you look at the original one, the tan inverse of x. And wherever there is a 1, you put an a. That is only for tan. So for tan inverse of x over a, wherever there's 1, you put an a. So it is a over x squared plus a squared, okay? But this one at the bottom, please, just know that this one at the bottom, we write it as a 1, but it's actually a 1 squared. So that is why this is an a squared, okay? So sorry for that. I'm sure you'll be like, what? Come on. Because 1 squared is just 1, so we don't have to put the squared. But the one in the denominator is actually a 1 squared. So that is why we had to put it as an a squared. Okay, now anyway, if I'm doing the integrals now, what about the integrals now? What, do I do integral of tan inverse? No. It's just like we never talked about the integral of tan. We didn't talk about him. We talked about the integral of sec squared because it's the one which we can go back and get tan. So that's the one we care about. So that's the same thing. We talk about the integral of this, 1 over x squared. Once you see a 1 over x squared plus 1 and you're integrating, your nerves wake up. I mean, everything about you, okay? You wake up and you're like, oh, that's tan inverse. Come on, I know that guy. So, okay, you're doing integral of 1 over x squared plus 1. Of course, you'll be like, this guy's, come on. I know that guy. That's tan inverse. I know him. So 1 over x squared plus 1. If you integrate, what you get? You get tan inverse of x. But you should put a constant of integration c. Okay? Now, do we care about tan inverse f of x? Not really. Honestly, no, we don't. Okay, but the one that I want you to know is this one, because that's the one you're asked of. Okay, that's the one they want you to know. Because if you go back to the one they want you to know, they said it was 1 over x squared plus a squared, which is just similar to this. So now you'll be like, okay, a squared, if I remove this a, so it is like 1 over times a, right? If I integrate this whole thing with the times a there, it is going to give me straight this thing, right? So now that a is not there, what is it going to be? Well, you have to divide by a. So you're going to, yes, you take it back here, but when you take it back here, divide by a. So, okay, what is it going to be? It's going to be 1 over a, then this thing, because we are integrating. So we are integrating, so it is going back, okay? It is 1 over a, then it says tan inverse of x over a. That's the one they want you to recall, so you can put it. So 1 over a then times tan inverse of, because if I just say it's tan inverse of x over a, that means there was an a on top there. But the a wasn't there, so that is why I've multiplied by 1 over a, because multiplying by 1 over a is like these things will cancel. You understand? So that is what it is. Okay, no problem. This is going to, these are your solutions. If you have this, then you should be good to go. Okay, these are your solutions, and let's meet when we now do some questions on this stuff, and let's see how far we can go. Okay, bye for now.